Good morning, everybody, and welcome to Climate Day here at IAC 2008. My name is Nick Shave from Logica. I'm also the GMES chair at the UK Space Trade Association. So I think we have a very busy day today. We have 3 plenary sessions. The first one here this morning is focused on Copernicus, the new name for GMES. We have 2 plenaries around the lunchtime period as well. One looking at space technology in support of natural hazards, and also the second plenary at lunchtime is around the GEOS contribution to global environment monitoring. And then this evening we have a highlight lecture as well from Professor Alan O'Neill, who's here with us this morning. So without further delay, I'd like to hand over to Alan to kick off this morning's activities. Thank you.
Thank you very much, Nick, and welcome to you all. Thank you for leaving behind part of your full Scottish breakfast to come here this morning. So I'm going to moderate the panel discussion that we're going to have, and I think I'll start by just a few opening remarks, none of which will be too surprising to you. First of all, I think it's true that climate change is the major scientific issue of the day, Higgs bosons, Large Hadron Colliders notwithstanding. And not only is it a major scientific issue, it's very high on the political agenda. The Intergovernmental Panel Change Fourth Assessment Report reported last year and reaffirmed that it's very likely that the hand of man has been witnessed on the climate change that we've seen over the last century. So we are in no doubt about the importance of the issue. Now, this discussion, this event this morning, is to discuss how the space-based services being developed in Europe can contribute to global initiatives to combat climate change, and in particular, to explain and consider what Europe is doing in this area, and in connection with that, the relevant initiative is something called Global Monitoring for Environment and Security, GMES, now rechristened, renamed Copernicus. Now, to help us through this event, we've got some distinguished panelists here, and I'll introduce them in a moment. And the idea is that we're going to consider a number of questions, and they're going to address these questions after we've had an introduction to the GMES program itself, and then there'll be an opportunity for you to challenge the panelists with questions from the floor. So could I have just to introduce the panel to begin with, and then I'll go on to just outlining briefly what questions we're going to address. Can I have the next slide, please? Is it me? No, it's not me. It has to do this. So first of all, I'm Alan O'Neill. I'm the director of the UK National Centre for Earth Observation. I'm based at the University of Reading. And then the panel from right to left, as you're looking at them, is Mr. Mikko Stralendorf from the GMES Bureau of the European Commission. And then on his right, Dr. Mark Doherty, Head of Exploitation and Services Division at ESA. Mr. Michael Rattenborg, Director of Operations EUMETSAT. Dr. Peter Stott, Head of Climate Variability Research at the Hadley Centre. And our MP, thank you for coming, Colin, this morning. Colin Challen, MP, Chair of the UK Government All-Party Climate Change Group. So thank you all for coming along and for being willing to participate in this event and this panel discussion. I think before I asked Mikko Stralendorf to outline the GMES program in a few slides, let me just indicate to you the questions that we're going to address subsequently. If I could have the next slide, please. So the first one then is, how important is long-term direct monitoring of climate change, and what is the impact on government policy? And so underneath this question is the basic issue is, do we need to put in place, and if so, what are our plans to do so, to have in place an observing system that can give us a long-term, highly calibrated, accurate record of how climate and more generally the environment has changed over past years, if not decades, as a basis for understanding what is going on, figuring out why it's going on, what the changes are, and then for having a better scientific basis for knowing what's likely to happen in the future and what action we need to take. Question number 2, next slide, please. So, well, you can read it yourself. Besides its benefits for operational services, is the Copernicus program effective for climate science? And I think the undercurrent of this particular question is, and perhaps Miko will correct me if he thinks I've got this wrong, I think when GMES/Copernicus was first envisaged and first conceived, it was thought about very much in providing routinely services for environmental information and for various sectors that have dependency on weather, climate and the environment. And I don't think that is an issue that's gone away. That is clearly important. The question then is, though, does that self-same functionality enable us to say, to have very useful information concerning climate variability and climate change? So that's the subtext of that question. Next question, please. And then, again, you can read this yourself. How will current and future operational meteorological programs contribute to Copernicus and climate-related services? So I suppose the subtext to this is, well, when Miko outlines GMES, we have to think about GMES in the context of the international program for Earth observation, and not least the very important information that's coming about climate from operational satellites that have been deployed first and foremost for operational weather forecasting, but provide information of enormous value for understanding and diagnosing climate change and also as a foundation for prediction. So I think that's the subtext of that question. So I'll repeat the question. We'll have the slides up again to remind ourselves what the questions are. I think at this point, well, I won't do that now. At this point, then, I'll introduce Miko Stralenberg, who will tell us about GMES and its program and status.
Good morning to you all. So GMES is now called Copernicus, and we have a slogan, absorbing our planet for a safer world. But let's get to why the European Commission is active in this area, because this is the simplest way of trying to push this into 5 minutes. For the European Commission or the European Union institutions, it's really about trying to have better policies, smart policies, and all the measures at all levels of government should be as good as they could. And we need better information to do that. So the GMES program was about sustaining that we have the right space and in situ observation networks secured for continuous delivery of information, and then try to add value to these raw data streams in a way by working them up to a EU-wide information service which would help directly, for example, the European Union in trying to think of new policies or evaluate how good the old ones are working. And this is not just valid for a European perspective, but this is also on a global level. Simplest to understand that global change is something we do together all over the globe, but the effects are seen on many levels. So from this idea, in the European Union, you always have to think about the wonderful work like subsidiarity, which means that what is the right level for the European Union to act. And there came this idea that the information production chain is very long for getting environmental information services. So let's try to help on the beginning so that it's easier for people to do more local information services. And this is one of the main drivers behind the GMES program. But it should all help in policy development and hopefully also stimulate new business, or we are quite sure it will do. But it is, like all European Union activities, not something just done by one place, but it has to involve the member states, and not just the European Union member states. There are also, for example, Switzerland and Norway on board, so Europe as a whole. And then the European Space Agency has from the beginning on been very active in this field, and we are getting new European-wide organizations involved into this, for example, UMETSAT. But the importance of a GMES program, which already was, let's say, envisioned 10 years ago, is getting all the more clear when we see that global change is now our main challenge and on a very high political level. So we need the frequent update of what's the state of the environment, and we need to better benchmark and adapt policies. And then, in effect, to try to find best new policies for having a positive impact on economy and on the state of environment. And so GMES, let's say, stepped onto the next stage by changing its name 2 weeks ago, Copernicus. It was not just like not liking the global mess word, but it was about also trying to show that now we are stepped over from having just a lot of plans into the future of really doing something concrete, and we are just in the business of doing this. One picture to show it all. The general architecture, I think, explains good the idea I was trying to give you, that what GMES tries to do is the ones with the wonderful sunshines on it. So GMES data acquisition tries to secure that there's sufficient amounts of observation infrastructure. That's space-based Earth observation data sets, but also in situ, which is all the other observation networks needed. Gather these, secure them so that we can do core services. And these core services we have in multiple disciplines, mainly in the Earth compartments, land, marine, and atmosphere. There will be one for climate, a cross-cutting exercise for these, and then we have emergency response and security services. And those then make a green area of GMES data distribution. And there we want to have a open access, free-for-all data policy so that we would maximize the use of information done from it. But this is all about the value-adding chain, and we hope also to see a lot of downstream services. That's the area for new business to emerge, but it's also definitely the downscaling of the information to the national levels, for example, very important part of what downstream services will be. And some of that will actually be important information to go into the core service level to be distributed to all. That's the yellow national production part. But this is how we have arranged our field. But climate change, as the main topic today, what we have in mind for that is that we have to even more stress a lot of our services planning has had already incorporated climate change as a very important, or even the most important issue to be addressed. But now, as it is so high on the political agenda, we want to do even more. And for us, that has been concretized in the things that we want to make sure that reanalysis is also sustained for a long-term perspective, so it will continuously be always made new when all the machinery for doing a reanalysis gets better. And the information targets have been more, let's say, clarified to us, that they have to be the global climate observing systems, essential climate variables. And we are active in those already for atmospheric composition ECVs. They will come from our core atmosphere service, where we are in negotiations to start the MAC project to do, let's say, a pre-operational phase already distributing information of these, all of the variables defined as atmospheric composition variables. In the marine area, we have most of the marine ECVs coming from the Marine Corps Service. There's a project My Ocean in negotiations at the moment. And for the Land Monitoring Corps Service, we will add a lot more to what we now have. We have a few terrestrial ECVs in the, let's say, ongoing projects for GMES, but we will add them in the next round of Framework Program 7. And then one of the main things is to make this information as easily accessible to socioeconomic modelers. And this will come by extracting the impact information from climate predictions and try to provide the equivalent information from past and current observations so that we can build up the socioeconomic modelers to get quickly to doing things on this. And this will mean also that we will have to look into the observation infrastructures and fill some gaps there, and they will mainly come from what GCOS has defined. But this is just an example of how, to make it more concrete, what we are doing. This is an example of what is a project still working and providing information at the moment in Mercy, and then it will be continued by MyOcean, hopefully, when we put a name under the contract. Beginning of next year, it should start. So the Marine Copernicus service, or CUR service, it's about collecting satellite observations, in situ observations, for example, from Argo network or from other marine observations, put them into models, so make an analysis, assimilate it, and then run forecast on it. And those information outputs from the analysis and the forecasts are mainly the services we want to provide. So what's the status of this operation? At the moment, we really are in the era of having pre-operational demonstration, which is coming from, let's say, outphasing research and development projects, and the next round kicking off within the next year, some even this year, most beginning next year. We actually have also opened now a funding opportunity for validating these core services in the now open FP7 space call in downstream with a deadline on the 4th December. So the idea is to get people to really use the core services and see how good they are so that we get the best level of information out of it. But the coming year is very important for us because 2 weeks ago in the Lille conference, our Commissioner Günther Verheugen made a very important, let's say, promise on his behalf for Copernicus that he will not, let's say, stretch it out to the next commissioner, which is changing in 2009, but he wants to push for having a legal act next year so that Copernicus becomes an operational European program, which means we are not anymore in the framework program research and development funding mechanism, but we have our own operational money to use for this. And this is a very important, let's say, step to really get into the business of delivering services, delivering operational information. And then 2011 and 2014 is really the real kickoff, hopefully, of making a difference, because we will have our first satellites operational, because that's one of the things we do, but I left it for Isa to get into this more and not just me having to say it. We will also have these Copernicus core services sustained and running all the time. So this is where we are now, and I hope we are already now stepped into the area of from pushing information to pulling information, because Copernicus is about being user-driven. That means we want a constant dialogue between the users and their needs with the providers. So we need really users for the information we are doing, because now we are still in the research and development, let's say, funding scheme. We can't be total operational, but because the pre-operationality is just on the doorstep, we like people to come and start pulling. And the web address EC Europe EU Copernicus is the place to start. And if you want to give any more concrete feedback, use our email address. I'm actually sure Copernicus Bureau at EC Europe EU is also working, but that's for sure. Thank you.
Thank you very much, Mikko. I think now we'll move straight into the panel discussion and the questions, and if I could have question number 1, please. And again, you can remind yourself by reading it. I needn't read it out. And the way we're going to work this is that the 2 people responding to this question are Peter Stott and Colin Challen. and they have, if I may say so, 5 minutes each. And I'm sure they won't mind if I stand up after 5 minutes just to remind them that I'm rapt in attention to what they're saying, but nevertheless we need to move on. So in that regard, Peter.
Okay, is my mic working? Good. I did have some pictures that go with this, so if we could have the next picture, we just move straight on to the next picture. Thank you. So, as Alan said, it's very clear that climate is changing. There's a wealth of evidence that climate is changing, and I think it's true to say that most of the world has woken up to the fact that we need to do something about this. Whether or not the world is aware of the urgency of the situation is an interesting and important question. And, of course, it is where climate monitoring and observations play a crucial role in both communicating that sense of urgency and also understanding what the sense of urgency might be in terms of what we need to do to reduce emissions to avoid particular, potentially very serious thresholds being crossed in the climate system. And then, of course, we know that we are going to have to adapt to a certain level of climate change. So these are the main motivations for the importance of monitoring of the climate system. And I'd like to go through that in a little bit more detail very briefly now with some pictures. So this shows here the evidence from the fourth assessment report. And in fact, there you have 3 examples of what we can do with climate monitoring and observations. And in fact, they reflect an awful lot of work that's gone in to compile those 3 data sets. Because one of the very important challenges that we have in this field is in combining data sets from many different sources that have different biases, that have different biases relative to each other, into data sets of this sort. And this, I believe, is a very important scientific challenge that we face. So at the top there we have the global surface temperature record, which is clearly showing a rise that is continuing now at a rate of about 0.2 degrees per decade or so. On top of that, of course, there is considerable variability. And again, this is we need to have the observations, the monitoring, to understand the relative roles the variability is playing on top of the climate signal, and that is very important to be aware of. And in the middle there we see the sea level rise, and there you can see where we've got the satellite data showing a rise of about 3 millimetres per year, overlain in the red on the earlier tide gauge data, and also we are seeing reductions of northern hemisphere snow cover. So that's just 3 examples. And there's a whole wealth of more evidence in the fourth assessment report. And indeed, when we put that information together with the models, there was very, very clear evidence, and more evidence is emerging all the time, of the human influence on the changing climate. We go to the next picture. But like I say, now the question now has moved on really from is the climate changing to how urgent is the situation. And a very good example of this is what's going on in the Arctic at the moment. This shows the Arctic sea ice cover in the last 2 Septembers, the September that we've just had. Now, the September in 2007 was the lowest ever recorded September sea ice, and then this year we've only just avoided breaking the record again. And this has led some to conclude, well, maybe we might see a completely Arctic sea free, an Arctic completely free of sea ice, maybe within 10 years. Well, this is very much an open scientific question. In fact, at the Hadley Centre, in the Met Office Hadley Centre, we have a model that seems to predict, hindcast the trends pretty well with our climate model, and that does not show an ice-free Arctic within 10 years. It shows a much later. We'll get to that much later. But nevertheless, it does indicate that we need those observations both to monitor what's happening and also to understand the processes involved. And we know that our models are deficient in a number of aspects in terms of how they simulate ice and snow. So passing quickly on then to the next picture, this shows some events, and of course, events drive policy, they drive the way people think, and this is how this will affect people's lives. It will be events. Of course, for such events, such as flooding that's as seen there, key questions here are, scientific questions are, how well can we quantify the probability of those events, the frequency of those events in a changing climate? We no longer live in a stationary climate. So what was happening in the past is no longer a predictor for the future. can we attribute the changes in the frequency of those events? Can we predict what's likely to happen in the future? And then on to the next, I think I have one more picture. And this shows a picture again, actually, from the fourth assessment report. And it shows projected runoff changes. And this is towards the end of this century, as predicted by models. But it shows some very dramatic changes and some very different changes in different parts of the world. You'll notice, particularly in the Mediterranean region, there's some very severe decreases in runoff predicted. Now, there's a lot of work to do here in terms of scientific work to improve our models so that we can better predict these changes. But I would say that it's very clear from the evidence I presented, hopefully you can see that monitoring is really vital to understanding the current vulnerability and to predict likely future changes.
Thank you, Peter. Peter's given us a nice example from the environment of events, dear boy, events. And with that, perhaps I can ask Colin to comment on the question.
Thank you very much, Alan. I'll just perhaps correct one thing in the introduction. I share the all-party Parliamentary Climate Change Group, which is an informal association of MPs from all sides of the House. It's not an official government group, so we are free to criticise the government. In fact, I thought I was going to be a bit late this morning, coming over from Edinburgh, which would have allowed me to say that whilst I'm fully committed to space, I'm sorry for being a bit late, and that is really perhaps HM government policy to a certain extent. As anybody who's involved in GMES, Copernicus will know, we are with perhaps cold feet addressing this issue. I think the government will be supporting it fully, and the decision will be made in just a few weeks' time. But I think it is a bit disturbing if we think that we can, in any way at all, freeload on the science. I don't think that's the general approach in Britain. The Hadley Centre is a brilliant contribution to global understanding of climate change science. I should also mention NERC, which is supporting a very important bit of research underwater, as it were, the North Atlantic Meridional Overturning Current. And I only mention that. It's not obviously a space issue, per se, but it's something that could affect us very deeply. We need to have a better understanding of the science so that we can be better politically informed and to make better judgments about cause and effect. But we're about to enter a period, quite possibly, where the climate in the North Hemisphere, or parts of the Northern Hemisphere, could cool considerably. Some people might say that this year's summer is an example of what it might be like. In those conditions, it's very difficult for politicians of any party to convince people that tough action is needed on climate change, especially when we now have this added bonus of the economic crisis, which I think, as we're all aware, is leading us to take our eye off the ball. So it is absolutely essential, in my view, that the science has to continue to get the investment. And I just read in The Guardian this morning of Hadley Centre's latest research, and it starts off this article saying, when it comes to climate change, the scientific evidence has to be at the core of any decision-making. I mean, that's absolutely essential, especially at a time when more and more people are going to be questioning the science for their own rather non-scientific reasons, and particularly at this time of economic crisis, which may continue for 2 or 3 years. We don't know how long this is going to play out. If anybody saw the Times yesterday, you would have seen arguments put forward by Bjorn Lomborg, our dear beloved friend, who is not sceptical about global warming, but is very sceptical about the money that we're spending on tackling it. Now, this is the debate where the sceptics have not yet been defeated. We might say that the science has been sorted, but the real scepticism now, I think, is in the political community, where there are plenty of people saying there are better things to spend the money on. So the science has to play a very, very important role in tackling that. We are at a crucial period. The EU is going to be, I think, leading the debate in the final year of the Bali roadmap, concluding in Copenhagen next year. We need this kind of resource to back up what we're saying, to back up the EU's tough targets on emissions reductions, on energy from alternative sources and so on, to prove to the rather sceptical Chinese, Indians, possibly not the Americans for much longer, but others, that they need to follow our example. And our example needs to be somewhat tougher. In areas such as deforestation, which contributes something getting on to 20% of carbon emissions, we need the science and the observation to measure the impact. I heard only yesterday that Brazil, through its own satellites, has discovered that the rate of deforestation is faster than they thought. That's the role of science, and I think the role of satellites and Earth observation, very important to tell us what's happening. It's also going to be extremely important in policing and monitoring any agreement that comes out of Copenhagen. It is absolutely central, and we should be at the forefront in this country, in my view. So I will be pushing for that this autumn. Thank you.
Thank you very much, Colin. A few points which I'm very pleased to hear. I mean, the UK government, Colin affirms, is looking at this GMES programme very, very seriously from an investment point of view, notwithstanding there are other calls, as always are, on government expenditure. I think he's noted the fact that the climate is likely to experience a number of twists and turns. It's not as though climate change is a given. We're going to get surprises and unexpected things happening in different parts of the world, so that the need for vigilance and monitoring is key, and as is science, because any policy action, any remedial action is going to depend on a strong science foundation for the decisions. So if we go on to the next question, and again you can read that for yourself, and to address that question, first of all, Mark Doherty.
Thanks, Alan. I guess the simple answer is that there can be no global research without global observations. And space is the platform par excellence from which to make global observations. I think it's also important to preface my intervention to say space alone cannot provide an adequate set of observations, and the whole principle of GMES system is to put together a system that properly combines in situ space observations in models. And the models incorporate our best physical understanding of the climate system, which, as Peter said, is far from perfect. The key contribution that GMES is going to bring is very simple. It's to assure long-term continuity of global observations, and continuity is a small word, but it's a colossal requirement, and one that it's absolutely mandatory to achieve. In simple terms, you've seen the lines, the time series that Peter showed. If you cut one of those lines and introduce a gap between them, you're no longer able to assess trends. So you have to maintain observations continuously, and they have to be calibrated and recalibrated, because the trends that you need to monitor for global climate are small on the time scales of years, but it's of crucial importance. So the first point is continuity and global observations. Consistency also, because you need to be able to compare data that was measured maybe 10, 20 years ago with the current data. And another interesting thing on the curves from the IPCC that Peter showed, and it's crucial, the crucial contribution that space brings. Not only do we have these long-term measurements, you'll see that the error bars, science is often more about what's in the errors than what's in the measurement. The error bars on all of those time series are decreasing. Why are they decreasing? Because the density and the frequency of measurements has progressively improved. And GMES, Copernicus, is really about now making the quantum leap. We have systems today that are making these types of observations. In Europe, and the European Space Agency, we have a heritage based on the ERS-1 satellite, which was launched in 1991, the ERS-2 satellite launched in 1994, and the ENVISAT satellite launched in 2002. So the measurements are already being made, but they're not being made frequently enough. They're not being made with adequate sampling. The science community is strongly engaged we just last week had 200 scientists from all over the world looking in detail at observations of ocean color and sea surface temperature and making clear recommendations about the future systems and how to join up these gaps. So we know what systems are needed. And frankly, we're not inventing some super-duper new observing system. We're improving the measurement systems that we have to guarantee this continuity. And it's about removing biases, adequate calibration and validation of the measurements, and characterization of the errors so that the research community can actually know what they're getting. It's rather basic, actually, but we are not yet doing it on a global scale. Now, climate requires more stringent, it has very specific and more stringent requirements than you would need for something like meteorology. Or for many practical day-to-day applications, you need more precision and accuracy because you're measuring these small trends, and you need stability. Now, if we actually look at what is being proposed to be built, and just to respond to Alan's initial question, GMES was initially conceived and is conceived as a system to serve many purposes, and this is really important. But it does address the basic climate needs. Now, there are a series of 5 satellite systems, constellations if you like, that are planned to be built and launched starting from 2012 onwards. They're the backbone of the observing system, and they cover the full suite of measurements that we know are possible and are necessary for climate and other applications. And the "and other applications," I repeat, is crucial. Now, just briefly to outline to you what these types of observations are. There's a radar imaging system that will provide global measurements with 20-meter resolution from a radar system. And that system has been flown on the previous ESA satellites. It's actually a system that Europe is in the lead in the world with. And to mention to you its relevance for climate. It's that system which allowed measurements of the increase in the outflow of the Greenland glaciers, a doubling in 10 years. It's that system which is allowing us today to monitor the breakup of the ice shelves in the Antarctic. And it's that system which the CI610, which has presented the measurements that Peter shown. It's shown last year and this year, and interestingly enough, observations which the models did not forecast. That's really important. So we're applying simple principles of science. We have models, we have hypotheses, but you must confront them with the observations. And guess what? The observations are constantly throwing up things that you don't expect. And you must be there making the observations on the global system. We have a system that will monitor global land change and a system called Sentinel-3, which presents a whole suite of observations that are all crucial for climate monitoring. Sea surface temperature to a precision of 0.1 degree Kelvin, which is what has been achieved with the ATSR system. Sea surface height variations with an accuracy of 2 to 3 centimeters. Ocean color and land vegetation measurements, which basically allow you to see the dynamics of the carbon cycle globally. And then systems that will monitor carbon dioxide in the atmosphere. Those are all measurements that allow the science research community to understand how the Earth system works. Now, just to finish on the point of "and the other applications." GMES is not a climate-only system. In fact, nobody owns the global problem. This is the real difficulty. Had we proposed GMES as a climate-only system 7 or 8 years ago, I promise you we would not have the financing that we have today. The awareness of the climate problem really accelerated mainly last year as a result of the IPCC. So cost efficiency, and in the economic crisis, it's crucial to put in place expensive space-based observing systems that serve many needs, and that's the essence of GMES.
Thank you. I mean, I'm glad you mentioned in terms of many needs, that one of the many needs is scientific need as well as applications and policy needs. And I think there has been some confusion in some quarters that GMES originally perhaps conceived, years ago maybe, as an operational system. And the question has been, well, really, is it very useful for science? If we look at the quality of the instruments and the specification of what they are seeking to measure and the importance of the measurements, there's no question that if the GMES is implemented as envisaged and with some enhancements, which I may talk about this evening, then it'll be of profound importance to science. Peter, if you don't mind, with that stage whisper, I'll skip you on this one, if I may. Is that okay? Do you want to add anything in particular to that? Support it? Add a sentence?
Yes, I agree. You made lots of very good points, a few of which I would have made as well. I think there are just two very quick points then. We must make sure that we find some funding model for making sure that we keep satellites up in a monitoring phase, that when they go from being researched to monitoring, because we need those continuous measurements. And then, just very quickly, always remember not to underestimate the scientific and intellectual effort required in producing these long-term records, because it's an issue of the homogenization of the data. And there have been stories in the past where, like, for example, the free atmosphere temperature trends, where the skeptics were saying that the atmosphere wasn't warming, and where basically it was a lack of understanding of the different biases in the different instruments. And now we have a much better understanding of that, and we understand that indeed the atmosphere is warming as expected.
Thank you. Thank you for getting all those valid points in despite my curtailment. My apologies for that, but I'm sure you understand. If we go on to question 3, please. And then you can read that. And I'll invite then Michael Rattenberg to address that one.
Thank you. I have a few slides to illustrate. So, next, please. I think what the operational agencies are bringing is, of course, their long-standing experience in processing of satellite data for meteorology, and the experience also in supporting climate projects. Our main contributions as an operational organization is provision of observational data, provision of expertise in generating products, including climate products, and of course the international cooperation framework in which we are involved and have been involved in since many years, like GCOS, GMES, CEOS, etc. Next, please. But first of all, we are offering continuity. The programs of the operational agencies span decades. Prime example of this is the Meteosat program, which is operated since 1977. We have at EUMETSAT a complete archive of the 30 years of satellite data, and since about 10, 12 years we have been supporting the ECMWF in their reanalysis project by reprocessing the data from these 30 years of archive, harmonizing them across the decades, and having an appreciable impact on the reanalysis activity. Also, this archive of data can support process studies like, for example, the Sahel dryout in the 80s, which is very accurately described through the data. So we're providing continuity, even though the Meteosat program is not directly designed for climate, because of the fact that we have a 30-year record of data with essentially the same sensors. We can contribute to climate monitoring. Next, please. Now, since 2006, we've had the MEDOP satellite in orbit, which is the first in a series of 3, which again, it will provide continuity up till around 2020 for data from the polar orbit. And the EPS, the MEDOP satellite, carries important payload for climate. I'd just like to mention the 2 sounding instruments, the YASI instrument operating in the thermal area, and the GOMI instrument operating in the ultraviolet. And these 2 instruments have important capabilities in deriving climate-relevant gases like methane or CO. This has been demonstrated since we launched the MEDOP satellite in 2006. Very important scientific studies in this area. And again, converting this into operational services, we will provide continuity for the next 15 years in providing data from these instruments. Another instrument that I'd like to mention is the GRASS instrument, radio occultation instrument, which some claim is actually the only true climate instrument because it is based on a measurement of the only quantity which is very precisely calibrated, namely time. It provides information about time delays, and therefore it is very precisely calibrated. And we also have other important instruments on MEDOP that are very valuable for the derivation of climate records. Next, please. Of course, we also have the JSON satellite EUMETSAT is involved in the JSON-2 program and are working very hard to expand this into the future to provide continuity of this very important climate record. Mean sea level rise, as quoted before, is one of the prominent essential climate variables. JSON is probably the only example of a satellite that directly provides information about an essential climate variable as a basic measurement. And thus we think that this is a very important mission for the future. We're also working in the CEOS context, have defined together with the other CEOS agencies an ocean surface topography constellation concept to ensure continuity of these measurements in the future, taking into account the missions that are already being planned, JSON, Sentinel-3, etc. Next, please. In moving into the climate area, we established a European-wide context, what we call satellite application facilities across Europe, and these, which are organized in thematic areas like ocean and sea ice, climate, atmospheric chemistry, etc. All these centers, led by European National Meteorological Services, are providing significant contributions to the climate relevant aspects of our activities. Next, please. So, of course, we understand that generating climate products is a very complex process. We need to first ensure the availability of long-time series of basic data. Then we have to provide very precise calibration. And then we have to start generating fundamental climate data records and thematic climate data records from these data. And this is a very long and complex process where you need to involve the scientific and technical expertise at all relevant stages. And we are working in this based on our archive availability of the archive since 1977, as I stated, also based on the activities of the climate monitoring satellite application facilities and others. Next, please. So just to show you what sort of process that we have set up, to the left you'll see the global observing system, so the different satellite sensors. We have established an initiative called G6 together with the other operational agencies in the world, so NOAA, JMA, CMA, and involving WMO and USGS as well, to provide intercalibration of all the operational systems together, not just the infrared sensors, but microwave, etc. So we're providing a context for intercalibrating the sensors to arrive at consistent calibration, again over decades, in order to support the generation of fundamental climate data records. We've also established a cooperation in the context of WMO between regional satellite centers on climate monitoring, also involving both meteorological and satellite agencies, to derive from these fundamental climate data records essential climate variables based on the meteorological centers, again addressing the express needs of the climate observing system. Next, please. So we're saying EUMETSAT has a clear mandate in our convention to contribute to climate monitoring. We're contributing with the generation and reprocessing of data to arrive at essential climate variables, and we're working in a lot of international cooperation initiatives, both in the WMO context, GMES, GEO, etc., to provide our capabilities into the area of climate monitoring. Thank you.
Thank you very much. And I think you've shown some really nice examples of where the deployment of satellites deemed to be of operational value is also of tremendous scientific value and value for climate research, and instruments like IAC and so on. I mean, without naming the others. Miko, do you have any brief comments to add to that?
I have two extra things to mention. Sorry, not working. Okay, so two things. For one, the meteorological services are, in a way, the best practice example for doing operational services. So that's many times the role model for how we want to do our information services in Copernicus. And it actually is already reality in the fact that, for example, for the atmospheric and the marine core services, there is a very heavy involvement of meteorological institutes, national meteorological institutes in those. So they are already in the loop of helping doing Copernicus a lot of good. The other point is that we want really to see the level of downstream services evolve quickly and be a strong user pull to what core services do. And in this area, the National Meteorological Services really, they are de facto, if you look at Earth observation, let's say, related service production, the meteorological services make a very big deal. The biggest part of the cake comes from Met services, so we hope that they can also find our core services to use and do new services, because that will quickly have a lot of those evolve. So two things: do downstream on the national level and help us in doing the core service.
Panelists for addressing those questions eloquently and keeping to time. Can I now move on to giving you the opportunity to ask questions which you can address to individual members of the panel or more broadly, and I'll do my best to spot you as microphones move around the auditorium. There's an awful tendency to pick people you know or people who are sitting in the front rows, so forgive me for that, and if I'm doing that, people with microphones, just ignore my suggestions and hand the microphone to somebody who looks desperate to ask a question. So we start here.
I'm Professor U.R. Rao, former chairman of the Indian Space Research Organization. What we know about the global warming and what we don't know about global warming are quite different. Certainly this program is an extremely important program. We still do not have the information on many of the issues. In fact, one of the latest things which has come out, which is a old theory, but again has been reinvigorated, is the effect of cosmic rays. There's an extremely good correlation between the cosmic rays and a low-level cloud cover. And now we know what happens, because if the solar heliomagnetic field changes, the cosmic ray intensity goes down. And if the cosmic ray intensity goes down, then that changes the nuclei on which the condensation can occur, and that changes the low cloud cover. And the contribution of that is now becoming fairly significant if one calculates. In fact, IPCC4 hasn't taken into account this totality. That comes to almost about 0.6 parts per meter squared, as against 1.66 of the carbon dioxide. The implications of this...
my apologies. I do apologize for interrupting you, but it's important. I think the tenor of your question has been understood. Please forgive me for the interruption. I'd rather now, if I may, ask the panel to respond. And by all means, you can take it up with the panel.
Yes.
Later.
No, I just want to say only a couple of sentences. And I think we need a long-term measurement of many, many parameters, including the outgoing radiation, solar long-wave radiation, and of course many of the things which we have, and the water vapor measurement. And India is also trying to sort of put up a satellite with all some of these measurements. Thank you.
Thank you. Anybody like to volunteer for that one? They're fighting amongst themselves. Peter looks as if he's emerging as the front runner.
Okay. Well, we did. There was actually quite some detailed discussion about the potential links between cosmic rays and the climate system in the fourth assessment report. It was discussed, and the evidence there was looked at. And one of the things that was noted there was that the apparent supposed rather good correlation between low clouds and cosmic rays had actually completely gone away in recent years. So the conclusion was that there was certainly no compelling evidence that cosmic rays were a major player in the climate, in global warming. You know, the greenhouse gases were very much the dominant player, along with lots of other human factors, and that cosmic rays were not a major player. However, that doesn't mean to say that we shouldn't continue to certainly monitor what's happening. That's clearly very important. I would certainly endorse that, and that we shouldn't indeed continue to try to understand better the very complex processes that are going on in the climate system, including the formation of clouds.
Mark will respond, and then Colin.
Yeah, just to mention, picking up on the point that there are many other parameters that should be measured, I think it's a very important point. And it's something that we in the European Space Agency, as a research and development organisation, have been confronted with. And it boils down to the ability of our member states in Europe to finance their needs and ambitions in science. We do not at present have a fully financed operational system to do global monitoring. That's what GMES is all about. It's about making that step and getting the finance. In parallel to that, ESA is developing a series of Earth Explorer missions which are responding to already identified needs for observations. Examples are soil moisture, ocean salinity and biomass. And if we are to proceed, we need to maintain both the development of new systems in parallel to a fully operational system. It's part of the big picture.
I'm glad you made that point. It's an extremely important point. The interleaving of the data continuity with high-quality instruments, but also the innovative, technologically pushing instruments that come along for particular aspects of science. Colin?
I just wanted to say, qualified to answer specific technical questions, obviously. But it just seems to me that these questions will arise. Sometimes they will seem to counter what we now understand about climate change. There might be trends possibly discovered which seem to run in the opposite direction as we spend more time and energy studying the issue. I think that's bound to happen. And I think it's very important that the scientific community understands that it has a responsibility, a deep responsibility to communicate exactly what's happening, because as I said in my opening remarks, I think there's a lot of there's a big audience out there waiting to hear the counter evidence, and so I think we have to be very calm and collected in the way that this evidence is presented, and how it's communicated is really important.
That's a very solid point. And again, to the questioner, please forgive me for cutting your question a bit short. I spotted two. One was here.
Yeah, Mike Taverna from Aviation Week and Space Technology. There's a movement apparently within some of the members of the European Space Agency saying that the first replica unit for the Sentinel satellites, the cost of these satellites would be better borne, or more, should be borne by the European Union and not by ESA. And I was just wondering, first of all, if you think, members of the panel think this is an idea which has merit, and second of all, for Mr. Stallendorf in particular, is this something which the European Union is prepared to consider?
Well, if I directly answer, the fact really is that the European Union is in this trying to get all the players to work together for something. And then it's usually also good that everybody puts a little bit money into it, because that makes, let's say, the organization streamline it in the right way to this fact. So I think this co-financing system we have for the Sentinels is pretty good. And in effect, of course, it's like ESA gets the money anyway from the member states, so in a way it is a system of just having many routes to put it together.
The current proposal that ESA is bringing to its Ministerial Council is to cover the financing of the B units, as you mentioned. That is the proposal. There are always debates, but that's the proposal that's on the table. And I think what's important is, yes, there can be debates about how it should be financed, but what is important that it's necessary now to build a fully operational monitoring system, not half a system.
I'd actually add into this that it is very important to see that for Copernicus to be a success, it is really that the three early partners, which was the European Union, its member states, and ESA, that they all are a part of this. And so what we are many times, let's say, not so sure of getting into it is the member states. That because there are so many of them, there's not one voice to say that if the Britons, for example, say, yes, we will be in and we will help our part, it doesn't mean that all of the member states are saying the same. But I think we have a consensus in this, that everybody is pushing for it. But that's why the let's say, financing is drawing from all of these sources so that everybody is feeling that they are on board.
Well, I'd just like to mention from the EUMETSAT point of view, in meteorology, the experience is that the sustained fund, if a program is to be sustained over decades, it has to be funded by the users. And that, I think, is what we need to transform Copernicus into a user-driven and user-funded system. Otherwise, it would not be possible to sustain it over decades.
Colin?
Can I just add that I think that's absolutely right, and if we did change the funding mechanism right at this critical period, would it be a wise thing to do? And would people think that the European Union would bring more layers of bureaucracy to the system? Would that slow things down? And as I understand it, as ESA's run at the moment, if a nation state puts in money, it gets an equal amount of investment in its own economy out of the system. So if the UK puts money in, we're going to be employing people in this country doing those jobs, and I think that is a relationship which may disappear with the EU and make people rather more sceptical.
Okay.
Okay, thank you. Bernard Frank from Europe. Yes, I was concerned that you address global warming only from the angle of some traditional parameters, weather, and sometimes the citizen doesn't see what is the local effect of that. So we should really communicate more on the fact that not only there is a very small trend, but also there is amplification in space, so geographical amplification and amplification in events. But also it's very important to integrate new set of measurements which are much more sensitive than humans. And for instance, see how vegetation patterns are changing. Can we see also in situ some changes in the genetic of various ecosystems and how they respond to this change? And I think that then we would have a much better description of global change. Not only climate. Climate is very difficult to communicate to public, but also what is going to influence our life, our quality of life. So what are the set of really next generation of biological indicators that you think we could monitor from space and from ground?
I think that's a very important point, particularly in regard to ecosystems. Can I just ask Mark if he would want to just comment, and then I'll move on to, I won't ask the panel to further comment, if I may. I'll take one last question after that.
Yeah, I think, thanks. I think that is the beauty of GMES. For example, the system that will monitor and is monitoring greenhouse gases is also providing a measure of aerosols and atmospheric gases that are damaging for health. So the same system that will be served climate will also, and today is resulting in services to people who have respiratory diseases in London getting a phone call telling them there may be a pollution outbreak tomorrow. And there are multiple examples that have been developed through the service development where the system is is monitoring globally and also providing the local services. It's the beauty of GMES.
Thank you, Mark. Mick, if you don't mind. Okay, very short.
It's very short because if it's actually defined in a way that Copernicus is filling gaps. There's not a gap in doing atmospheric physical parameters. The meteorological community is totally taking care of those on a global level. Like, it's the good example. And Copernicus is actually going after all the other things. So it's the atmospheric composition, so the chemistry of the atmosphere, which we have in our atmosphere services, not the meteorology. So, and then obviously the marine and the terrestrial is just going after what you were asking for. So the vegetation is a very important part of what we want to see in our land monitoring core services.
Dick Klein, coming from an area by DC where we just got 7.5 inches of rain in one day, that brought up questions about what the effect might be of climate on our weather at that time period. And I think what Bernard was saying earlier, and what I also feel, is that ways that we can interrelate or relate the effect of the climate activity, and rather than talking just about the 1 degree C change in temperature, that does not, in my opinion, communicate to many of the people who will provide the very, very mandatory increase in funding that we all need.
I mean, just to give you a practical example, there is a major policy decision that is getting major funding called RED, Reducing Emissions by Deforestation in Developing Countries. Colin mentioned that that particular phenomenon represents up to 20% of global emissions in CO2. I don't have to tell you about the economic consequences of that. The system that is being built, and in particular Sentinel-2, is a system that will provide observations of global forests at 10-metre resolution, and in practical terms can provide an observation system that would enable the developed countries to actually regulate what sort of economic incentive and payments they provide to the developing countries who are busy chopping their forest down. That's a very practical thing, and it affects the dollar or the euro in everyone's pockets.
Yeah, well, I think this was an excellent example of what we are actually going for, and that is actually also, if I was talking in very overgeneral in policies, we need new policies for like global change mitigation or climate change mitigation, and that is really not about the weather. We can't make a policy, yeah, the temperature has to drop 1 degree globally, but we need to go for the other things which really affect us because of it, and which affect the system. So I think that's just what Copernicus wants to do.
I'm going to close the session now. That stage whisper was Mark Doherty saying to me, why don't you talk about the forecasting and prediction? And actually, that's going to be the main basis of my talk this evening. That's not advertising. I don't suggest you waste good whiskey drinking time to come to my talk, but if you want to come, that's going to be the central focus of it. I'm just going to close with some very, very brief remarks. I think we're all aware we're confronted by a significant societal and scientific challenge. I think we're at a very important stage around the world in deciding on our level of investments to help us understand and manage the changes that are going to come upon us, some of which will be perhaps predictable, some will be quite unexpected. I think we've heard today about the European effort with regard to GMES Copernicus, and I think it's clear to me and others on the panel that this effort must be part of a worldwide integrated international effort involving not just ESA, EUMETSAT, but other space agencies around the world. And we have bodies around the world that look after or consider the coordination in satellite and other related programs. So I think that is something that gives us great responsibility for managing the changes that we're imposing on the world at the moment and leaving a legacy for generations to come. I want to close by a couple of just points, trying to summarize many important points that the panel have made. I think if I can summarize an important point that Colin Challen made, I think he's affirmed that the UK government is taking GMES Copernicus very, very seriously, and the seriousness will obviously play its way out in the coming months as decisions about levels of funding are going to come before the public. So we hope, at least I do, speaking personally, that there'll be a good, solid outcome in that regard. At the same time, Colin has reminded us that scientists have a major job of explaining the issues involved to the public and policymakers so that real rational decisions can be made. And I think that's something we have to make greater efforts to do than we've perhaps done in the past. So I'll take on that challenge equally to Colin's accepting the responsibility of the UK government to consider seriously the issue before them. The other important point, I think, came up from Miko Stralenberg, and correct me, Miko, if you think I'm misrepresenting you. I think he made a point somewhat in passing about I think he said a free-for-all data policy. I don't know if those are my words or his words, but the implication is there'll be free access to the data emanating from the GMES system. Can I confirm, or would you like to qualify what I've just said there? Because I think that's a very important point for people to understand quite fully.
You're absolutely correct. It's just the what is always the most important question in a data policy. So for many, that's the part which has to be more defined to understand that open and free access is really what we go for, and which we will have, for example, for our next round of core service demonstrator pre-operational services. They will provide it free and openly access to anyone, but it's these information services, because that's what we as the Commission or the European Union is playing for, there we can impose a data policy which is open and free. For many of the data sets we need for those services to be done, we would very much like to just say the same, free for all and everyone, but we don't own those data, so we can't define the data policy for them. We are sorry for that. We are actually pushing for that sector to realize how much better it is to have an open and free access data policy, but it's really up to them to make the change.
Right. Well, I'm very glad you've made the comment that we would like to see a free and open access data policy, notwithstanding there may be some restrictions on some aspects of the service provision coming out of GMES. With that, I would ask you to thank our panel for doing a very good job of answering the questions that were posed to them and also the questions that came from the floor. Thank you very much indeed, folks. And with that, I'll bring things to a close. Thank you very much.